Question 22 says, what is the mole fraction of solute and the molality for an aqueous solution that is 25% NaOH by mass? This is when we really need to know our definitions. 25% by mass is equal to 25 grams of NaOH divided by 100 grams of solution. Now, solution is a combination of your solute and your solvent. And since it says it's an aqueous solution, we know our solvent is water. So we need to know what is the moles of water at some point. So we can do that by subtracting, since we know this is just combined of if I do 100 grams minus 25 grams of NaOH, I'm left with 75 grams of water. So that's how much water was in this solution. And now it's asking for mole fraction and molality. It might be easier to start with molality since we now have grams of H2O. Molality is going to be moles of NaOH divided by kilograms of H2O. And I can convert 75 grams to kilograms by dividing it by 1,000. So that's just going to be 0.075 kilograms. Now I need to get moles of NaOH. If I have 25 grams of NaOH, I can convert that to moles of NaOH by dividing it by the molecular weight. So if I have 25 grams of NaOH, and I know the molecular weight of NaOH is 40, so 1 mole divided by 40 grams of NaOH will cancel out those grams, and I'm left with 0.625 moles of NaOH, and that's going to go down here, and now I can actually find our molality. Now we need to know our mole fraction. We now know moles of NaOH. We need to figure out how many moles of water. If I have 75 grams of water, and I want to get to moles of water, I need to use the molecular weight. And that gives me 4.162 moles of H2O. So for the mole fraction of the solute is going to be equal to the moles of solute, which is NaOH, divided by your moles of solute, plus moles of water or solvent. So the mole fraction of NaOH is equal to 0.13. Question 23 says a solution is made by dissolving 0.854 moles of non-electrolyte, which is a key word, in 578 grams of benzene. A, calculate the freezing point of the solution. So the freezing point of the solution is going to be the freezing point of the pure solvent minus the freezing point depression. And the freezing point depression is going to be Kf times molality. Kf is given to us because it does say that the solution is benzene. So we have to use the Kf of benzene, which is 5.12. And we need to know what the molality is. So molality is moles divided by kilograms. So we have 0.854 moles of solute and 578 grams of benzene. We just need to convert that to kilograms. And that is going to be equal to 1.48 molality. So to find that change or that freezing point depression, I just now have to plug everything in. Those molalities are going to cancel, and my freezing point depression is equal to negative 7.58 degrees Celsius. Now we need to know what is the freezing point of the solution. So the freezing point of the solution is going to be the freezing point of your pure solvent. So for benzene, that's going to be 5.49. Minus your freezing point depression, so 7.58 degrees Celsius. So that's going to be negative 2.087 degrees Celsius. Don't forget this last step, because even though you did everything right, it's not calculating this freezing point of your solution, it's just calculating your freezing point depression. Part B says calculate the boiling point of this solution. So it's similar equations. Your delta TB is equal to KB times molality, and we calculated the molality was 1.48 from the previous part. The KB in benzene is 2.53. So we can now calculate our boiling point elevation. The m's are going to cancel, and the boiling point elevation is equal to 3.74 degrees Celsius. So our boiling point of our solution is going to be equal to our boiling point of the pure solvent plus your boiling point elevation. So that's going to be our boiling point of your pure solvent, 80.10 plus 3.74. So our delta TB, our boiling point of the solution is equal to 83.8 degrees Celsius.